Good morning, everyone. I am Tsu-Jae King Liu, Dean of the College of Engineering here at UC Berkeley, and it's my pleasure to welcome you to what I'm sure you'll find to be a lively discussion. I especially want to welcome back any alumni who are here with us today, as well as current students and their families. I'm really glad that you could join us. As you may know, Berkeley Engineering is at the epicenter of innovations to address the world's most pressing challenges. Our faculty here and students are conducting research at the cutting edge to help shape a future for all that will be healthy, resilient, sustainable, and equitable. So today, I'm really delighted that a few of our outstanding faculty are here to share with us what they are doing. And these faculty include Professor Ashok Gadgil and his collaborator, V. Rapp, who will be discussing their work to develop a device that offers warmth to newborn infants to help prevent infant hypothermia. Ashok holds the Andrew and Virginia Rudd Family Foundation Chair, and he is a professor in the Department of Civil and Environmental Engineering with expertise in safe water and sanitation. He is also a senior faculty scientist at the Lawrence Berkeley National Lab, where V. Rapp is an environmental technology research scientist. Next, you'll hear from Professor Ting Xu, who will talk about how her lab has invented a way to make compostable plastics break down more easily with just heat and water within a few weeks, solving a problem that has flummoxed the plastics industry and environmentalists. Ting is a professor of material science and engineering, an affiliate with the Kavli Energy Nanoscience Institute. Finally, but not least, Assistant Professor Rediete Abebe will discuss the design of algorithms for social good. Her research seeks to improve societal welfare, as well as income shocks faced by poorer families due to a layoff or missed paycheck. Abebe is an assistant professor in the Department of Electrical Engineering and Computer Sciences, and she also co-founded Black in AI, which is a nonprofit on a mission to diversify the AI profession. To begin, I would like to ask each of you to give a brief overview of your research and what you are most excited about in your field. Following that, we will have a discussion. And to members of the audience, I'd like to invite you to submit your questions via the Q&A function at the bottom of your Zoom screen, and we will address those questions at the end of all the presentations. So I'd like to invite Ashok to get us started, and following Ashok's presentation, Ting and Rediete will share their research with you. Ashok?
Thank you very much. Dean Tsu-Jae, it's my great pleasure to be here, and I'm going to start with sharing my screen. There we go. Let's see how this goes. Go to full screen, and that should work. Can you see this all right?
Yes.
Okay, terrific. So I'm going to talk about a persistent problem about child deaths or babies dying in the developing world. And it's something that we should be able to address, and that's what we are trying to do, and that's what I'm going to describe, what we have done so far. Okay. My colleague V. Rapp was supposed to join me, but owing to a personal commitment that came up at the very last minute, she can't. She sends her personal greetings, and she really sorry to miss this occasion to meet and greet her alma mater alumni. She also has a PhD from engineering, College of Engineering, UC Berkeley, mechanical. So when we try to solve real world problems, it requires expertise from multiple fields. And I'm going to talk about my slice of it, which is engineering, but it requires the ability to work with many other experts. And that leads me to the next slide, acknowledging whom we worked with. So Anne Hansen is the professor of pediatrics at Harvard Medical School and the director of NICU, that is Neonatal Intensive Care Unit, at Boston Children's Hospital. Everett Mahidama works in Uganda. He's a lead medical scientist in Partners in Health. Jonathan Slack, Mike Elam are with LBL, and then there are lots of people in Harvard and Rwanda and with UC Berkeley. Too many to put on this slide, but I want to acknowledge that this is not a whole team here. Going next. So what's the problem with infants? Why so many babies die of cold? Infants are prone to hypothermia, and the ratio of body surface area to body mass in metric units is how the medical field defines this. And compared to adults, infants have way, way more surface area and therefore heat loss. And they don't produce heat that well. And once the core body temperature drops below 35 C, as you can see over here, things really go downhill from there on, and particularly for infants. So it's a common cause of infant mortality. About 2.7 million babies die in the first month of their life every year, out of which 1 million die, or of those deaths involve hypothermia. And the ones who do survive hypothermia have a lot of difficulty growing up normally. But the irony of that is that infant deaths from cold are preventable, and we should be able to stop infant deaths from cold. That's what this project is about. In the context that we are talking about, where most of these deaths occur, more than 90%, facilities are poor. Here, look at this waiting room. Look at this maternity ward. Look at the level of cleanliness on these curtains. Look at the, So electricity is unreliable. Resources are limited. Makes it very hard to operate the first world level of care, or standard of care as we call it, in these contexts. So we need something that is going to be robust and reliable and very safe, even in conditions where these conditions prevail. That's the norm, okay? So NICU, neonatal intensive care unit incubators, range from about maybe $18,000 to $35,000. They're too expensive. They quickly fail for lack of spare parts, or lack of even diagnostics of what went wrong, or simply lack of electricity. On the right-hand side, you see one of these incubators lying around, a low-tech one, relatively, but still just being used as a junk. It doesn't work there very well. The other alternative is, it works well. It is called kangaroo mother care, or skin-to-skin contact. It's free, but it can be inadequate for low birth weight infants, or if the mother is sick, or if the mother herself is struggling because of a very difficult delivery. So we need something that will work, which is almost free, way cheaper than $35,000 or $20,000, reliable, safe, and will work with kangaroo mother care, rather than trying to fight something that is already implemented well by UNICEF and WHO. So we need a safe, affordable, non-electric warmer compatible with KMC, which must be electricity free, must be affordably low cost. And what our design evolved is about 1 kilogram of plant-based wax with a melting point that is just below the desired body temperature, and a very good engineered form factor to allow the heat transfer to do the job. Okay, so essentially all these wax shapes are in the form of candles. The candles are put together, as you see in this center box here. You can see my pointer. You put the candles in a bucket, you pour boiling water onto the candles, they all melt, become transparent. You look at the indicator that shows that it's not too hot, because you don't want to burn the baby. This water was boiling, remember? And then you slide it into this mat, and there is a mat with the kangaroo mother care and a happy mom and even a happier nurse with KMC. And here is a case without KMC, both in Rwanda. So how well does this work, and where are we now? We did a phase 1 testing way back in Rwanda in 17-18. And we found that there were no adverse events. 99% of the babies achieved or maintained euthermia. It was reliable. And we published a paper, but it was time to find the defects that come up when you really do a field trial. The temperature indicator was failure prone and very expensive. and everything was handmade. The mats were handmade, and it cost a lot of time and effort to make every single mat. So our goal was to make something that is reliable and robust for temperature indication and machine manufacturable so that it can be done rapidly and still maintain the cost to be low. This is what happened. This is Dr. VRAP, and this is I holding the mat together, partially melted. And those little red tickets you see at the top are the indicators. When the ticket is transparent, the wax is too hot. And when that little ticket is opaque, you see, you cannot see the finger through it, it's good to use. It's as simple as that. And that red ticket is made out of a different wax that has a higher melting point, and that can go for 100,000 cycles, and the incremental cost is negligible. We did a phase 2 study in Rwanda, 2019 and 2020, just as a pandemic broke out. For 5 months, the study was stopped because of the pandemic, but the Rwandan government allowed this to be the first project to restart because they are very engaged and excited and committed to see if this works, and they would like to adopt it. The key point is that almost 90% infants achieved or maintained euthermia, and the mortality rate dropped by threefold to 0.9% among the infants compared to the rest of the infant population in these public hospitals, where the mortality rate was 2.8%. And the significance of the result is extraordinarily good. 0.01 is super, published in the Lancet. So where are we going now? There is a nonprofit now founded with leadership from Harvard Medical School with Dr. Ann Hansen as the chair of the board. It's called globalnewborn.org. We are working on improving the design, getting manufacturing and sourcing, and find and consolidate partnerships. And that's where we'll stop. This is really, really exciting work with a huge impact on people who normally don't have access to good healthcare. Thank you very much.
Thank you so much, Ashok. This is truly amazing, life-saving innovation that you and V have innovated. So it's so inspiring. Thank you. Next, we're going to have Professor Ting Xu. She's already prepared a recorded presentation, and so we will be viewing that next.
Okay, excellent. All right, so it's indeed a pleasure for me to be here and share with you some of the work we have done. Let's just talk about plastic. Plastic actually is not a particular old field if you compare to many other disciplines. 1920, the micromolecule hypothesis was first proposed, and it was awarded by the Nobel Prize in 1953. So back then, people didn't believe that plastic exists. So this is one of the advice was given to Professor Staudinger, which was a Nobel laureate. And then fast forward in about a few years, especially right after World War II, nylon was introduced, and the production increased drastically. And for those of you who may be interested in, what this picture is, that is the Macy's in Market Street in San Francisco. That is when they have a penthouse sale. That's how popular it is. Many of you probably already watched the movie The Graduate, and you probably remember the episode. There's only one word was given, and that word is plastic. If you look into this table, this sort of captured the history of different plastics that we're using daily, the timeline when they were produced. You can see it really hasn't been that long before plastic completely dominate our world. And let's just look at here, fast forward in 2020, there's about 400 million metric tons of plastic being produced annually at the global level. And nearly 40% of that actually become a package into the packaging industry, and they become a single-use plastic. They are definitely over-engineered. They get used once and then subsequently get tossed out. And this turned out to be the majority of where the plastic waste come in. And there's a lot of interest in the community to move forward and really try to reduce plastic waste. Here are just a few companies that pledged to change their packaging materials to either to be fully recyclable or reduce the amount of plastic they are going to use. And in this particular area, people are very much interested in the biodegradable plastics, because biodegradable plastics has been studied in the biomedical field. So you go into a doctor's office, you may have a sutures, but it will just dissolve on its own. You don't need to go back to doctor's office to take it off. So people had hypotheses maybe 10, 15, 20 years ago, basically saying that if I have a biodegradable materials to get into this packaging field, then they should be able to dissolve like what they did in our body. And then we should be able to solve the single-use plastic issue. So in fact, the global market responded. So you can see that currently the biodegradable plastic is about $3.7 billion and is projected to basically triple in just a few years. And for the US alone, this is a bar that shows that different plastic that is being used. You can see starch is for sure is one, will be ideal for us to replace starch because of the food. And then PLA, polylactic acid, as well as PBAT are another two important plastics. So that all sounds good. And we know if we use biodegradable plastic as a biomaterials, whether using as coating, biomimetic coating, or controlled release, or use it for the implant material, they do disappear. So what's the problem when we start to use them for the single-use plastic, in particular in the packaging area? So at 2015, this is one of the reports come out from United Nations, basically saying that the so-called biodegradable plastic make no difference comparison to their polyolefin when they come into the trash. They linger around, and in fact, they are more problematic because they generate a microplastic much faster than their polyolefin counterpart. So there has been some movement saying that forget about the biodegradable plastic. It sounds really good, that it really doesn't do anything good. Let's go back to the polyolefin, go back to petroleum-based materials, which I don't think is a solution. So let's go back and look at why biodegradable plastic are degradable in the first place. Here are just the chemical structure, the few materials I mentioned before. And what you see is that for them, you have this distinctive ester bond. And that's the magic chemical bond, why they can become biodegradable. There's a lot of enzymes that in our daily metabolic, they just do the work to hydrolyze the ester bond. It's one of the common thing. And in fact, the enzyme we use are routinely used in the dairy industry to basically go through the hydrolysis of this ester bond. So everything should be good, but why it has been so problematic? And we supported by the ICOR program, we went through, did customer discovery along the value chain. And this is basically what we learned. From the manufacturer, from the customer point of view, there are significant incentives for the field to move toward compostable, especially in the packaging industry. And they are willing to bear the cost. But what happened is that because this biodegradable plastic are not degrading within the time frame of composting facility, which oftentimes is operated at a 6-day cycle rather than a much longer. They become a contamination, so they have to be sorted out. So if you go into Berkeley Marina, look at taking the compost, oftentimes you can see those green biodegradable plastic bags linger around. So there is a significant danger if we don't solve that problem, because people are reverting back. And in fact, in Australia, there has been some serious discussions in the policymaker. So this is where we start looking into what we can contribute to the field in order to move it forward. We believe biodegradable is the way to go, and it's the best process forward for us to really form harmony with the nature. But we also need to identify what is made the difference that they are not degradable. Well, they're degradable just fine with our body. One important issue is that when you have the plastic in the wild, the enzymes are not readily available. And even if the enzyme are available, they start to corrode from the surface. The corrosion process is really slow. So that's why they linger around. So we have been thinking about perhaps if we carry the enzyme within the plastic, then it doesn't matter where it goes. All you have to do is when to trigger it when you need it. But it's not that simple, because when you start to carry the enzyme within the plastic, there's a lot of fundamental science you need to study. You need to maintain the enzyme stability. And then the most important, you need to start to look at the materials at the nanometer. This is where nanoscience comes into play. Enzyme only a few nanometer in size. And when you look at the polymer chains, especially in the semi-crystalline polymers, they are hierarchically structured. They have structure features going from a few angstrom all the way to the millimeter to the microscopic level. So if you want to interface enzyme with your bulk plastic product in a seamless way, you have to really modulate how the interplay is going to go at all sorts of event scales. And we just discussed about the microplastic issues. Getting plastic degraded is not the solution. You have to really degrade all the way down to a small molecule where the microbes can use them as a food for their metabolics. If you have just break it down into a short polymer chain, that still linger around. It's not going to solve the problem. And that requires you to really work with the enzyme at the individual enzyme level so that it's going to function either from, in this case, we wanted to bind at the chain end so that it only bite off one molecule at a time, rather than just do a random chain session, just bite it all over the place and just leave small molecules. So this really requires us to disperse as well as stabilize enzyme within the plastic. And this go back to a technology we reported back 2018. I would call it really the secret ingredient. How can you maintain the enzyme to be active in a foreign environment, as well as how can you use it to disperse the enzyme so that they are function at the single polymer chain level. So once you have that, with the work we perform, we are able to disperse the enzyme within the plastic nanoscopically. And what is important here is this is a piece of microplastic, and what you see green are where the enzymes are still retained. And you can see even the form microplastic enzyme are still carry, and enzymes still continue to do the work. And if we can get in there, just want to show you that we indeed can degrade the polymer chain into a small molecule, and that molecule can be subsequently used by the microbes, rather than what you do before that, you're just making a whole bunch of small, shorter polymer fragment. Being an engineer, once we understand the science, we have to really think about how this can be processed in a scalable fashion and using existing plastic production infrastructure, because the industry is not going to change just because this is more environmentally friendly. So we performed the work, and most of the plastic is using melt extrusion. That's what we did. And we also wanted to look at from the customer point of view, want to make it possible to do in-house composting. And this, we were fairly lucky that now we were able to compost this enzyme-containing plastic just using warm water. So it's there's a lot of people I have to thank. And on the top are the graduate team we have in our group. I do want to highlight that Aaron Hall right now is a CEO in Tropic Materials, is working to commercialize the product. And we cannot thank enough of our undergrad. At any given time, we oftentimes have almost 20 undergrad working in my lab. And this group are currently really working hard trying to move this enzyme-containing biodegradable plastic forward to really going from basic science as well as to the engineering the prototype. And here are just a few undergrad which we had just in recent years. They all move on, have a great life. So with that, I'm happy to answer questions, and I think I will finish my presentation and happy to answer questions.
Thanks so much, Ting. I think the audience members can enter questions in the Q&A chat box, and we'll proceed at this time to Professor Rediete Abebe to give her live presentation.
Very good. Let me just try to screen share and make sure that that all works. Good. Okay, can you all see this? And did the slides just advance?
Yes.
Okay, very good. Just confirming. Very good. Thank you so much to Dean Liu and to everyone else on the team for pulling together this event. It's my first Berkeley homecoming, so I'm happy to be here, and I'm happy to represent my department and my field at this event. And I want to talk to you all today a little bit about my field more generally. So I'm not going to talk about too many particular details of of our projects, but what I want to show you is sort of why I'm excited to be at Berkeley and why I'm excited to be working in this area at this time. So as you all know, the world is going through a really hard time. We are living through a pandemic, continue to be living through a pandemic that's now infected over 200 million people. And I believe close to 4.5 million people have now succumbed to this disease and died. Here in the United States, we've seen violence against Black and African Americans and immigrants kind of reaching a breaking point over the past couple of years, and especially last summer comes to mind. But these issues have been there for quite some time and have been sort of weighing on the kind of day-to-day lives of marginalized communities for a very long time. And we also see these issues kind of intersecting in pretty unsustainable and crushing ways. So with this pandemic, we've seen Black and Latinx and also Native American individuals being infected at 2 to 3 times the rate of the general population, and also being hospitalized at almost 4 to 5 times and dying at twice as much as the general population. And likewise, even with sort of assistance that we've been offering in the United States, that hasn't really reached everyone. So if you think about, for instance, immigrant communities, and especially those who have undocumented individuals and their families, they've been essentially excluded from some much needed relief, despite being sort of an essential part of the economy, and especially lines of work that have been very exposed through this pandemic. And so, it's a really hard time, but we've been living through a very hard time for a while. And so it's natural to ask, what the heck are we going to do, right? And how can I, for instance, as someone who's a computer scientist who works with data science and algorithms, how can I help contribute to better understanding these issues, and also seeing if there may be opportunities to move things in a way that is kind of helping bring us out of some of these really challenging times that we're living in. But there too, we have a lot of bad news, right? So as a computer scientist, I'm painfully aware of times when attempts to actually help have completely backfired, right? So there's work, for instance, by Professor Ziad Obermeyer, who's at the School of Public Health, that shows that algorithms that are used in healthcare show anti-Black racial bias. Right, and you might also be aware of all the work in the criminal justice and the criminal system space, as well as also algorithms used for poverty reduction and alleviation. Again, actually doing the exact opposite of what they intended to be doing, and punishing and penalizing poor people rather than actually assisting individuals that are disadvantaged and underserved. And so a large body of work, including a lot of folks actually here in the information school at Berkeley, have shown that there's kind of common pitfalls that computing tends to fall into when thinking about social change. So there's a sort of a tendency, for instance, to potentially be a solutionist, right? To assume that computing and algorithms will solve all of our social problems and everything else is a sort of secondary consideration. You can also see sort of tinkering that happens, right? Rather than actually trying to address the root of problems, there's maybe a tendency to see a lot of things as fixed and try to kind of tinker and optimize around potentially problematic social political systems. And there's a sort of diversion that happens, right? The moment you say algorithms, people get really excited excited. And maybe that actually detracts away from other ways of addressing these issues and really from grappling with the root of these social problems that long predate this field. And so this is kind of a lot of bad news, right? So this was sort of, a lot of this was happening, a lot of these discussions were happening around the time that I started my PhD at Cornell in 2015. And it was really, I mean, as someone who was interested in using these kind of computational tools in my work and really excited about research in that space, but also painfully aware of the disadvantage that a lot of communities have to live through. It was a genuine question that I asked myself, and then my colleagues and I discussed over a period of essentially my entire PhD, whether computing has any roles to play at all in social change, whether we should really just kind of close down the whole field, or at least kind of leave ourselves and try to tackle these social problems in other ways. And as I mentioned, we end up having this conversation over a period of many, many years. And as a result, we actually ended up writing this paper that I highly recommend you read if you're interested in this area, called Roles for Computing and Social Change. And I kind of want to give you a sampling of some of the roles that we were able to identify through our conversations that was outlined also in detail in this paper. And effectively, what the bulk of our argument is making is saying that social change, as we've seen historically, is the work of many hands, right? So no one field, no one group of people is going to really solve anything. That we all kind of have a role to play, and that there's a sort of an ecosystem of agents that need to come together to push towards these kinds of long overdue changes that we want to see to build more resilient and equitable societies. And so we thought about ways that computing can support other routes to social change, not necessarily supplant them, not try to replace anything. And we kind of went through a lot of examples that we've seen from our broader field to identify whether there's some common patterns that sort of emerged in terms of the role that computing was playing in trying to advance some issues in a more positive direction. And we identified 4 roles. I'm not going to go through all 4 of them, but I do want to give you just kind of one example, which is the role of computing as a diagnostic, right? So computing can be very good at, especially when you have kind of large amounts of data or kind of a more nuanced understanding of a problem that allows you to kind of poke at some issues that might be harder to untangle otherwise. In those situations, computing can be really helpful in measuring social issues and diagnosing how they manifest in technical systems, right? So this is not meant to solve anything. It's just saying there's some issue here, and we're trying to understand the contours of this social social issue, especially if it's kind of showing up in these technical systems that we've built. And that may be better, that might improve our understanding of this problem, and that might lead to potentially highlighting directions of change. So to give you an example, this is work that is really, kind of one of the first papers in this area of sort of algorithmic fairness. This is work by Dr. Latanya Sweeney. Dr. Latanya Sweeney is an African-American professor at Harvard University. And in her work, she was actually, I think she was inspired by just Googling her name and seeing that at the time, you would see these ads popping up that say, has Dr. Latanya Sweeney been arrested? And, questions around like defaulting and things like that, right? So discriminatory ads that were not true or fair, but it was showing up because Dr. Latanya Sweeney is an African-American individual with a name that's commonly associated with African-American community members. And this was kind of like a very robust observation that kept coming up over and over again. And so in this work, Dr. Sweeney highlights how these issues are permeating across our ad delivery systems and how that might be leading to perpetuation of discrimination in ad platforms. And really, if you think about this broader space, there's a lot of papers, including the healthcare algorithms paper that I mentioned earlier by Ziad Obermeyer and others, that show that this kind of diagnostic role that computing can play can really be useful in bringing to light and surface social issues that we may not have necessarily seen otherwise, or to bring to light and also kind of really show the extent of these problems, right? Sometimes we have a tendency to sort of underestimate or downplay these problems. And so my own work has also done this. So one thing that we did a couple of years back was we were engaged in issues of health in the African continent. And this was something that was really that I was inspired by because of my upbringing in Ethiopia. And one thing that I noticed and that we all know is that health information can play a really important role in combating the burden of diseases. And I think now we're painfully aware of that as a result of the pandemic. But a lot of times you might not even know what knowledge individuals have or communities have, what knowledge they're seeking, what misinformation might be out there, and sort of what gaps in people's understanding of a disease there might be in order to provide sort of targeted education efforts. And so what we did was we used sort of a large a data set, search queries to sort of show the landscape of information that people were seeking. So these were questions around sort of symptoms and drugs and breastfeeding. This is related to HIV and AIDS, but then also things that are very hard to measure around stigma and discrimination, natural cures and remedies, and healthy lifestyles for individuals living with HIV and AIDS. And this was already very helpful to kind of bring to the forefront what information people were seeking and where we might be seeing some misinformation. But we also engaged kind of with the content that people were getting in return. So if you were searching for instance, can I get fired if I'm HIV positive, right? Which indicates that there is stigma and discrimination that's happening. What content are you now seeing on, the search engine? And is the quality of that content high as measured by relevance, accuracy, and objectivity as measured by health experts? And so we did this exercise. We went through this extensive study, and we were able to show that for questions around stigma and discrimination, breastfeeding, and drugs for HIV and AIDS, the quality of the content was reasonably high, rating at average of 4 or more out of 5. Whereas for questions around symptoms and also especially questions around natural cures and remedies that people were asking for HIV and AIDS, it was quite low, rating at, for the natural cures one, it was rating at about 1.5 out of 5. So there were frequently a lot of serious issues. And there are many reasons why this was happening. One of it was, of course, the content that people are asking, right? If you're asking for, does garlic cure HIV, then you might be getting a certain kind of content, as opposed to, say, if you asked for, what are some like treatments, antiretroviral treatments for HIV and AIDS. But it wasn't just the questions that people were asking. There was also a lot of discrepancy in back-end processing that was happening in the search engines. And so if you search for something, and let's say, and there's a typo, or maybe there's something that you phrased a little bit off, there's stuff that happens in the background that you don't necessarily see that helps map your question to better quality content. And that was happening significantly less for questions related to natural cure and remedies, as opposed to, say, antiretroviral drugs. But then the other issue was also just the content that's available on the web. So if you focused on high authority websites like the CDC, UNAIDS, NIH, and the WHO, and you only wanted to get content from those websites, from these high authority websites, even if you were asking whatever question you were asking, the backend processing was doing an excellent job, however you wanted to find that. If there were no web pages out there that I could show you when you ask for, does garlic cure HIV, then instead of these high authority websites, what's going to instead fill in the space is blogs and Yahoo Answers and other kind of low quality content like this, right? And so we were able to detail this in our work. And so this is just meant to give you a flavor of this role of computing as a diagnostic. But I want to emphasize here that just diagnosing something does not necessarily mean that you now have a solution, that you now have a treatment that you want to proceed with. And in particular, a quote by Dr. Ruha Benjamin stands out. Dr. Ruha Benjamin is a professor of sociology and African American studies at Princeton University. And in her work, she says, data, in short, do not speak for themselves. They don't always change hearts and minds or policy. And this is something that we've seen over and over again. We know that issues around incarceration or issues around homelessness, or even just the pandemic, if we're thinking about that, we've seen the extent of problems and how bad things have gone and have been evolving over time. And that hasn't necessarily changed people's hearts or minds or policy, right? And so it's very important to keep that in mind. And in particular, I want to highlight that as researchers in general, as computer science researchers in particular, we have a responsibility for how our research is understood, used, and influencing what's happening out in the world. And in particular, it's very common to hear things around the impact of our work, and for people to say, well, look, I'm just an engineer, I'm just a computer scientist, this is the engineer's job, or this is the policymaker's job, or I didn't consider that subpopulation, I guess that's the problem, or, oh, that's just an implementation issue, it's outside of the scope of our research, or I didn't consider that, I guess it couldn't have been, that serious, right? To sort of take issues that impact marginalized communities and really see it as being out of scope, take issues of translating our research into practice and see that as being out of scope. And that's where a lot of things kind of fall through the cracks, and we end up causing a lot of harm on communities. And to avoid that, there's a lot that we can do, including sort of building partnerships with domain experts from fields that we're working with, and especially affected communities that should help us formulate the problems that we're trying to tackle, and also the implementation of any interventions that we're considering. And this is work, that I've engaged in since the beginning of grad school. At the time, I started this along with a colleague of mine, Kara Goldner, who's now a professor at BU. We started a small online reading group, and this was back in 2016, way before online things were fashionable. So at the time, it was kind of an innovation. And this small online reading group that was predominantly graduate students has now kind of exploded into this massive institution, massive initiative that includes thousands of people from hundreds of institutions in over 50 countries. And we had started a lot of different things like online working groups and an online colloquium series and a workshop series. And this has sort of blossomed really and has been a huge part of my growth as a researcher, but it's also blossomed into a conference, an ACM conference that is happening on Tuesday. So in 3 days, there's going to be an ACM conference on equity and access and algorithms, mechanisms, and optimization. If you go to emo.org, you can find information on it and you can attend. And this is a conference that is very multidisciplinary and also really focused on working with practitioners, not necessarily people in academia, not necessarily people in research. And so I encourage you to check out the MD4SG Initiative that I mentioned, and also the conference, and reach out if you have any questions for me as well. Thank you.
Thanks so much, Rediete. That was wonderful. I think hopefully the audience, we can see how impactful all of this research is to ensure a more equitable future and also sustainable and healthy. I thought I maybe would start out with just one general question for each of the panelists here. How do students, especially undergraduate students, I think many who are with us today or their families are with us today, how can they participate in research projects? I know, Ting, you already mentioned that many students are working with you. I assume for both Ashok and Rediete that you also have undergraduate student researchers, but what is the best way for students to learn about and have these opportunities to work with you all? Why don't we start with Ashok?
So that's a very good question, and I think it's really, really important for me to allow the opportunities that Berkeley always offers for undergraduate students in particular, and also to graduate students, to taste what research feels like by participating in it. I have, much like Ting mentioned, in her case, I have undergraduates participating and taking research credit units that Berkeley encourages and allows, so that it's part of their normal educational curriculum that they will participate in some research. And even in my classes that I teach, there are project-based classes where teams of students actually take on the project and pursue it for a whole semester under my guidance as an instructor. So there are multiple ways in which this happens. And I can tell you, once you taste what research is like, you don't want to give it up. I hope that happens to some more students.
Wonderful. How about Ting? Do you have anything to add to that?
I think for undergrad research, it goes both ways. On one end, students wanted to explore. On the other end, we have a lot of projects that we want to be suitable for the undergrad. So for us, from the graduate as well as postdoc training point of view, we want them to mentor undergrad. It's a very important part of their maturing process to get it ready for the next stage. So do feel free to reach out and explore different opportunities.
Yeah, maybe directly with the graduate students who are teaching assistants for your courses, right?
Absolutely, yeah.
All right, and Rediete, what do you think?
Oh, I love this question. I have to say the Berkeley undergraduate student body is one of my favorite communities ever. I mean, this is some of the most energetic and clear-minded people that I've ever met. Really, it just, I wish I could redo my undergrad here. I think I would have had a great time. So I just started, less than a year ago. So I haven't had much of an opportunity, but I've had a chance to work with a few undergraduate students here at Berkeley. And what's happened in several instances is that, I had a particular project in mind and well scoped out, and, I recruited students and I wanted to talk to them about it. And in the span of a couple of conversations, it was obvious to me that they had their own ideas that they wanted to pursue. And so, my projects keep not happening, and I end up picking up new projects as a result of the students, but I've really loved it. It's a community of students that I think they know what they want. And when given resources, they just, kind of run with it. And it's been really amazing for me to see that. And so if you go to my website, as positions become available, I'm going to post them. But more than that, what I've been really thinking about is how to scale this kind of engagement. There's a lot of undergraduate students that are really interested in these issues of equity and also in computer science and data science. And we have, some classes that touch on that sort of for a few units or a few classes, right? But we really need a class that's exactly on that. And so this is something that I'm designing. It's a class that I hope will be sort of a very large undergraduate class and an opportunity for me to meet, not just like, tens of undergraduates, but maybe hundreds, maybe even thousands of undergraduates over time, right? And so it's something I'm really invested in. It's going to take me a little bit of time to figure it out, but I will. And so if you just go to my website, I'll keep people posted, and I'm just really excited about further opportunities to engage with the undergraduates, the wonderful undergraduates that we have at Berkeley.
Excellent, thank you. There was one question entered quite some time ago by Taiwan. I think it's directed towards Ting. Let's see, what is the question? Is there some particular application? Is that right, Ting?
Yeah.
So
yeah,
so because of the time, let me just jump into it. I think it depends. Okay. We actually did, this is one of the beauty for being in the College of Engineering, because you have to start to think about how to bring things to the market. And it's while we're in the ivory tower, we think of one thing. So we went through this, we did about 200 interviews with customer designs. I can tell you where it's going to go. Socially, from what to do is right. People want to do it for, get to see it in the grocery store, and they want to see it in your daily life. Anything we throw away, you see in the shore, in the marina, that's what people want. On the other end, when you start to think about value chain, the profit margin, people are more interested in those high profit margin and want to replace multi-layer plastic bags that give you a better gas, a better property, lightweight, a better mechanical properties. So right now, I think working with Aaron Hall, which is CEO of Entropic Materials, as well as with some of the federal agencies, I think we are busy pursuing both directions, because that's going to give us a balanced portfolio.
Great. I know time is up, but maybe we can give you all one chance to answer one question that's been entered. Can you comment on the interest in your work from large corporations? Just really quickly, maybe starting with Ashok again.
Not for the infant warmer yet, but I'm very sure we will be able to engage interest once our result just came out in 2021, showing the threefold drop in infant mortality. So it takes time to develop that traction, but through the nonprofit route, we are talking to large corporations potentially as donors to go on to phase 3 now, larger trial, because that is what we need, and then go on to different markets. This only costs $100, not thousands of dollars, what we are talking about. And it could be a standard packaged product that pharmaceutical supply companies to hospitals could easily offer in large quantities.
Yes. Absolutely. Ting, how about you? Large corporations interested in your work?
Yeah, I think we right now, yes. So just give a few, I think the mother company of 7-Eleven and Pepsi, Coca-Cola, PG&E, Rediete from Europe. Literally anytime you get into normal grocery store and you see the packaging, the company, there's a lot. So we are actually working with Apera in building the IP portfolio, and then also start to think about what is the best way. We also get a lot of interest from VCs. And I think Aaron right now, even taking cash without string attached, he was able to demand that. That was pretty surprised. I think we also get a lot of interest from the federal agencies. They approach us out in the SBIR. I think it really reflected the community's interest as well as commitment to really make the change to the plastic industry. And we are really fortunate to be in the middle of it.
Excellent. And Rediete, how about for your work?
Oh, I'm sorry to give such a different answer to everyone else. So there has been a lot of interest from large tech corporations in my work, but I made a commitment several years back to minimize my interaction with large tech corporations as much as possible. I see them as being a huge part of the problem about why algorithmic inequity and injustice has been such a massive issue, and an issue that we don't really seem to have a very good answer to. And so I've made a commitment not to to minimize my engagement. I think as computer scientists, we are really entangled and dependent on large tech corporations at our own expense, if I'm being honest. And also we seem to not really want to work with public and civic sector organizations because we're just so caught up in our own academia and then big tech corporations, and that's kind of all that we have the energy and time for. And so my own work is actually really interested in trying to minimize that link as much as possible and trying to strengthen ties with other lines of work where I think we could be having a lot of really positive impact. So yeah, so there has been interest, but it has been one I've been dodging. So
good way to answer the question. There is interest from large corporations, but you don't think that's the right thing, for achieving social justice. Yeah.
Yeah. Not how things are set up right now. Yeah. Not without regulations of them, not without, breaking them up significantly. Yeah.
That makes good sense. Excellent. Well, thank you all to all the panelists for your time today. It's really inspiring and really impactful. Thank you so much for your time. And I'd like to thank all members of the audience. I'd like to remind everybody that the recording of this session, probably edited, will be posted on the College of Engineering YouTube channel in a short while. So I invite you to view that if you have any, if you thought you might have missed something. So thank you again, alumni and families, for joining us today. And I hope we can gather again together in person for actually this lecture next year. But please enjoy the rest of the homecoming weekend, and go Bears.